Okay, class, we will be starting our new topic. In our previous lecture, we covered series and parallel circuits, and we looked at a few examples how to solve series and parallel circuit problems. Now today, we shall be talking about Kirchhoff's current law and voltage law. So let's first look at the Kirchhoff's current law. It is the algebraic sum of all currents at a node or junction in an electrical circuit is equal to 0. It means if you look here, this is a node. Node is you can say a junction or joining point of different wires. At this particular node, the algebraic sums of currents entering and leaving would be 0. Another definition is given as the sum of the currents flowing into a node is equal to the sum of the currents flowing out of that node. So there are two ways to explain it. As you can see on this particular node, I1 and I2 are entering into this node, and I3 and I4 are leaving this node. So we can say that current entering, total current entering is equal to total current leaving, okay, which is specifying in the second definition. Or we can say the algebraic sum of all the currents, all four currents, if you add them together, taking care of their sign, plus or minus, then their total addition would be equal to 0. I hope it is pretty much clear. So let's see how to write the equation for such a case. For this particular case as shown, the equation could be written as I1 plus I2 is equal to I3 and I4. So I1 and I2 are entering the node, I3 and I4 are leaving the node, and both are equal. So for example, here uh, will tell you how to solve problems using Kirchhoff's current law. So first example, let's have a look on this. Find current I3 at the node shown below. So this is a node, a similar node as one above. So here we have some numbers. We have the values of different currents. I1 is 2 ampere, I2 is 9 ampere, I3 is unknown, and I4 is 4 amperes. So we will be using the Kirchhoff's current law, and according to that, current entering in the node is equal to current leaving the node. So we will be putting that formula, substituting the known values. So you will put all the values except I3, which is unknown, and rest is simple. You have to solve for I3. So just take 4 to the other side of the equation, and after solving you will find I3 as 7 ampere. So this was pretty easy. Let's have another example. Example 2 says find currents I3 and I4 at the nodes N1 and N2 shown below. Now in this case there are two nodes. N1 is here at this point, this one is N2, and there are different currents involved here. Each current is specified with the arrow to show its flow. Is it flowing into a node or out of a node? So now here in this case we have to find two currents. One is I3, one is I4. So as there are two nodes available, N1 and N2, so we will try to develop two different equations for both the nodes using Kirchhoff's current law. So let's have a look at the solution. At node N1, I1 flows into N1 and I2 and I3 are flowing out N1. So as you can see here, only I1 is flowing into the node 1. The other two currents I3 and I2, they are leaving. So we can write the equation like this, that I1 is equal to I2 plus I3. Now substitute the values. I1 is 5, I2 is 9, and I3 is 1. Keep it as it is. Rest is now simple. After making the equation, rest is a simple algebraic solution. So just solve the equation and you will find I3 as minus 4 amperes. So that's how the minus sign specifies that this current is leaving the node. The current entering the node would be positive and leaving the node is negative. Now, so far we found I3. We still have I4 to find. For that we can use this particular node N2. If you look at N2, here you will see that two currents, I3 and I5, they are entering the node and I4 is leaving the node. So at node N2, I3 and I5 flows into the N2 and I4 leaves out of N2. So you will write the equation like this. The two currents entering the node on one side and one leaving the node on the other side of the equation. So now we can substitute the values. I3 we just found as minus 4. So we will put minus 4 in place of I3. I5 is 10. Let's double check. Yes, I5 is 10. It is also in the node. So here it is. I5 is 10 is equal to I4, which is unknown. We need to find it. After solving, we can clearly say that I4 is 6 ampere. Okay, so that's how you solve the uh, current. You can find current in any circuit, in any simple circuit, by just making Kirchhoff's current law equation for any particular node, and you can find the current value. So this was all about Kirchhoff's current law. The same scientist Kirchhoff, he also formulated Kirchhoff's voltage law. In that law it says, in any closed loop of electrical circuit, the algebraic sum of all voltages around the loop is equal to 0. So sum of all the voltages is equal to 0. Loop means this is a loop. This is a closed circuit, okay, having one path. So this is a loop and there are three components involved in this circuit. One is this the supply voltage, one is resistance R1 and one is resistance R2. So there are total three components. So there will be three voltages. One is the supply voltage, one is the voltage drop on R1 and a voltage drop on R2. Now we have to make an equation for this, okay, but we have to take care of the signs. Some voltage polarity could be positive and some could be negative. How to find out that? For that you have to draw an arrow like this, which shows the flow of current in the loop. Okay, so as for the conventional current, we assume the direction of current from positive to negative. So from this source, the current is flowing out from the positive and going to the negative. The same direction is being specified by this arrow. Now we will go through this loop anti-clockwise, because this arrow is giving you a direction of clockwise. This arrow is giving you direction of clockwise. So we will follow the same. And if you see, each component polarity has been mentioned here. Okay, this supply, you can see its negative side and positive side. The resistor R1 positive and negative side is mentioned, R2 positive and negative side is mentioned. So when you go across this loop, in the clockwise direction, if you are facing the negative side of the component first, you put that voltage as negative. Moving on further, if you face the positive side of any component first, you put the voltage drop on that as positive. So let's see how the equation is made here. So this is the equation. So we are following this arrow clockwise. So first, if I start from here, first I see this supply voltage E, okay, and it has negative sign. I came across the negative sign first, so I will put negative E here. Then moving on in the same direction, moving in the loop, I came across the second component, which is R1. Voltage on this I will call it as VR1, and I put a positive sign with this because I faced the positive polarity first. Similarly, following in the loop, I came across R2 and its positive sign first. So the voltage on this would be plus VR2. So adding all the voltage drops, their summation should be equal to 0. This is what the Kirchhoff's voltage law is. There is a note here, footnote says the voltage polarities for voltage source and voltage across passive components such as resistors has to be respected and the signs taken care of. So you must take care of the signs and then set the polarity like this, okay, with each voltage. Now the further clarification we can do by example. Example 1 is use Kirchhoff's law of voltage and all possible closed loop to write equations involving voltages in the circuit below and explain the signs of the voltages. So this is a circuit here. There are no values given for any current or voltages. We just have to formulate the equations using Kirchhoff's voltage law for all the loops. Now, in this circuit, there are more than one loops. If you look closely, see this is one loop here. Loop is a closed path. This is one loop containing the source voltage R1 and R2. This is the first loop. Second loop is here. Okay, this is the second loop containing resistor R2 and R3. Only two components in this. And the third one is this, the whole circuit. It's full loop. This one. Okay, which has the voltage source R1, R3. Okay, the outer loop. Now you will not include R2 here because the third loop is the outer loop. So any components lying in the outer loop will be accounted for. So in the outer loop, you will take voltage source R1 and R3 only. That's it. We have to develop equation for all three loops. So how to do that? Step 1, set negative and positive polarities for all voltages, sources and across passive components. Positive and negative polarities are already set here. You can see that. Okay, so step 2, while going around the loop, if you face the negative polarity first, then write voltage on the component as negative and vice versa. The same rule which I explained you before. So now writing equation for loop 1. For loop 1, which is here, okay, I can, if I follow this arrow clockwise direction, the first component I came across is the voltage, and because I am looking at the negative side first, so I will take it as minus E. Moving on next, I see resistor R1, so voltage on this I will take it as positive. Then moving next, I saw resistor R2 and its positive side first, so I will take voltage on this as positive. So there are only three components, so I will write my equation like this: minus E plus VR1 plus VR2, and all summation equal to 0. So this is the Kirchhoff's voltage equation for loop 1. Following the same principles, I will write equation for loop 2. Let's see what is in their loop 2. In loop 2, only two components are there, R2 and R3. Okay, and I'm going to follow this clockwise direction. So first I'm coming across resistor R2, and see, I'm looking at the negative sign first. Okay, so I will take it as minus voltage minus VR2. Then moving on here, I will see the resistor R3 positive side first. So I will write its voltage as positive VR3. So the same thing is mentioned here, minus VR2 plus VR3 equal 0. Now talking about the last loop. The last loop is the outer loop, the bigger loop, following the same rules. Going and clockwise, I see the voltage source first with the negative sign first. So I will call it minus E, then positive VR1, then positive VR3, and that's it. I reached back to the same voltage source. So the same equation is written here: minus E plus positive VR1 plus VR3 equals 0. So that's how you develop uh, Kirchhoff's voltage equations like that. So this example was only to give you a practice on how to develop the equations. Next example is with the numbers. Okay, now here example 2 says in the circuit below, E1 is 20 volts, E1 is here, this voltage source is 20 volts, VR1 is 5 volts, VR1 means voltage on resistor 1, that is 5 volts, E2 is 10 volts, E2 is here, it is 10 volts. Find the voltages VR2 and VR3. Now here you have to find two voltages, VR2 voltage on this component and VR3 voltage on this component. Okay, so we will try to solve this question by formulating equations for each loop. So let me bring up on side by side. Okay, so I brought this window so that we can see the circuit all the time while we are solving the question. The solution here. So first thing that we have to find voltage on this resistor R2, VR2, and then we have to find voltage on this VR3. So I can make use of loop 1 to find this voltage here, VR2. Once I have voltage on R2, then I can make use of loop 2, this one here, to find voltage on R3. So let's do the first thing first. Apply Kirchhoff's law of voltage to loop 1 and write the equation. So this is the loop 1. Go clockwise. The first component we came across is the voltage source with negative polarity first. So I will write minus E here. Moving on, I can see resistor R1 with positive polarity first. So I will write VR1, which is here. And then moving along, I can see resistor R2 with positive sign first. So I can write plus VR2. So I have successfully formulated Kirchhoff's voltage equation. Now the rest is simple. I just need to substitute the values. As you know that this one voltage E1 is given as 20 volts. So I just put here 20. The minus sign was already there. So I just copied that minus sign. Voltage on R1 was given as 5 volts, as you can see. So I just put 5 here. VR2 we don't know, we need to find it. So rest is easy, you just solve this equation and you can easily find voltage on resistor 2 as 15 volts. So now we know how much is the voltage on this, 15 volts. Now we still have to find voltage on resistor R3, which is called VR3. Okay, I will repeat this step again. See, we have to find two voltages, VR2 and VR3. Okay, so this is my solution. VR2 is voltage on this resistor. Okay, let's only talk about VR2 now. To solve this, if you look at this circuit overall, there are three available loops. This loop here, which is covering the voltage source E1, R1 and R2. This is the first loop. Second loop is here, which is covering the components R2, voltage source E2 and R3. And there is a third loop which is covering the outer loop. You can see the where I am hovering my mouse cursor. So here you have voltage source E1, then you have R1, then you have voltage source E2, then you have R3. So this is your outer loop, third loop. Okay. Now my problem is to find voltage on this resistor. This resistor is in loop 1. So let's focus on loop 1 and try to write a Kirchhoff's voltage equation for this loop. Okay. The direction of current is shown here in this red arrow and it is clockwise. So I will move on clockwise. I will come across this voltage source E1, then I will come across R1, then R2, and then back to the voltage source. So this way I will follow and I will write voltages on all these components in like an equation. Okay. But some voltages are negative, some positive. How I will identify that some voltage is positive or negative? I told you the rule of thumb. The thumb rule is that if you see the negative sign first, I am I'm coming the clockwise direction and I reach this voltage source E1 and I saw its negative polarity first. So I will write minus E1. So here I wrote it minus E. Moving along, same clockwise direction, I came across resistor R1 and now I saw the positive sign first. So I will write voltage on this as plus VR1. The same I wrote here, plus VR1. Now moving along clockwise direction, I came across resistor R2 with positive sign first. So I will write its voltage as plus VR2. So plus VR2 is written here. So this is my equation. And Kirchhoff's voltage law says the sum of all these voltages will be 0. Now my equation is made. Now I can substitute the numbers, whatever I know. I know that E1 is 20, so I will write 20 here. Okay. The minus sign, because we already equation says it is negative, so negative 20 you will write. Plus VR1 is 5 volts, plus 5 I will write. And VR2 we don't know, we will keep it as it is, equals 0. The remaining is easy, you just have to solve this equation and you will find the voltage VR2 as 15 volts. Now, second part of the question says you need to find voltage on this resistor R3, VR3. For that, we can make use of this second loop. In the second loop, we have three components, R2, E2 and R3. Okay, voltage on R2 we know it is 15 volts. E2 we know it is 10 volts. It is given in the question. And voltage on R3 VR3 we need to find out. So simply follow the same current flow which is given in the circuit diagram clockwise. So start over from here. This resistor R2, okay, you see is negative sign first. Look at this arrow. So you will write minus VR2. Voltage on this as minus. So minus VR2 I have written my first term. Then I will move along clockwise and I come across voltage source E2 and I look at the negative sign first. I will write minus E2. So minus E2 is written here. Then moving along, I come across this resistor R3 with positive polarity first. I saw its positive side first. So I will write voltage on this as plus VR3. So plus VR3 is written here. So this is my equation. There is no other component, no fourth component, only three. So I will just write all three equals 0. So this is my Kirchhoff's voltage equation for loop 2. Now I have to simply put the values. So VR2 is 15 volts. I put 15 here. Negative sign, you have don't forget to put the negative sign because according to this uh, rule, when I followed the path, this VR2 is negative. So E2 is 10 volts, so I put 10, and VR3 we don't know, so just write VR3. Solve the equation and you find the voltage as 25 volts. So that's how we have find both VR2 and VR3, both the voltages we have found. Now is a additional step. What about loop L3, the outer loop? If we apply the Kirchhoff's voltage law, that will also satisfy. I mean, it should prove us that voltage on this loop should be zero, equal to zero. So let's follow this current path, the red arrow. The first voltage as minus E1, it is here. Second voltage on this plus VR1, plus VR1 is written here. Moving along this voltage, I saw a negative sign first, so I will write minus E2. Okay, then moving along on this VR3, I saw plus polarity first, so I will write plus VR3. So this is the equation for the outer loop. We are just doing it. This is not required in the question. We are just doing it to testify, to check Kirchhoff's voltage law, that is it really giving us a zero answer or not. Substitute all the values. E1 is 20, VR1 is 5, E2 is 10, and VR3 is 25. Okay, so when you add all of these, the answer will be 0. So the above equation will satisfy Kirchhoff's law of voltage. So that's how you use Kirchhoff's current law and Kirchhoff's voltage law to solve simple circuits, to solve for current and solve for voltage. I will stop the recording and open for question answer session.